All right, this last one here is on the fourth trend, average rate of change and average value. This one here is really straightforward. So I'll show you a little bit of both there, okay? I think our first one occurs right here with our traffic flow problem. Okay, so we'll do part C and then we'll do part D since it has average value and average rate of change, okay? So here in part C, average value is basically when you're integrating and you're averaging it out, okay? Average value means you're integrating the function. So here it says from 10 to 15, but then you average it out. So you do 1 over 15 minus 10. Okay, that is the average value, okay? You plug that in, you're going to get your answer, okay? So here's the thing. When you are, and you know what? I'll take care of this part too, the indicate units of measure, okay? I don't know what this comes out to, and it really doesn't matter because you could just do that yourself. Okay, so F represents the traffic flow, which is in cars per minute. When you integrate, let me go ahead and move this real quick. So if you don't consider that part, the integral itself would represent just the amount of cars. Okay, F is the rate, so you integrate, you're going to get just the amount of cars. Now think about what happens when I attach this 1 over 15 minus 10. Okay, so actually let me do that again. So this alone represents the amount of cars. Okay, but if I take this over here, think about what 15 minus 10 represents. 15 and 10 is a representation of time. So in this case, it's minutes. So we're dividing by minutes. It becomes a rate again. So average value stays the same. So it's going to be something cars per minute. Even if you didn't know how to do average value, you should have been able to figure out the units of measure. Okay? We'll take a look at the scoring guidelines after, okay? Here's part D, the average rate of change, AROC. Okay? How do you think we do that? So basically you use your function. It's going to be f of 15 minus f of 10 over 15 minus 10. Very similar to what we had, okay, but a little bit different. Average rate of change is slope between 2 points, okay? So here, again, you could use your calculator. I would probably use the y1 function, so y1 of 15 minus y1 of 10, all in parentheses, divided by all in parentheses 15 minus 10. You don't want any syntax errors there, okay? And then you get your answer, and it says indicate units of measure. So you do the same thing. F is measured in cars per minute. So I'm going to put cars per minute up here. 15 minus 10 is a measurement of time, so I'm going to put minutes. So that right there is actually cars per minute, or cars per minute squared. Okay, now obviously you have a calculator to get your values, but that's as far as it goes. Know the difference between average value. Value has an integration. Average rate of change is really just slope. Okay, but take a look at this here, and I think this is where it's really gonna hit most students. 2004, let me find it. Did I skip it? Okay, here we go. Traffic flow. Take a look at these points here. It is ridiculous, all right? Part C, what is the average flow? Okay, so they wrote 1 over 5. We wrote over 1 over 15 minus 10. Equal is equal, it doesn't matter. You get 1 point. Even if you didn't know how to do the whole problem, you get partial credit. You get 1 point just for putting the integral from 10 to 15. Okay, You get 1 point for just putting the function in the integral. And then you get 1 point for the answer, just for 81.899. Okay? In part D, it's straight up answer. Okay? So either of these two. But then they give you a bonus point. If you got the units in parts C and D, you get 1 more point. Cars per minute and cars per minute squared. Okay? If you take a look there, it racks up a lot of points. That's a 5-pointer right there. Okay? So there you have it. Okay? Let me see if there's anything else worthwhile. Let me see. That one you guys can do. I guess we can do this one. Okay, part B. What is the average rate of change in the height of water in the can over the 60-day period? Actually, no, this is not a good one. That one takes a little bit. Okay, here you go. Very straightforward. Find the average rate of change of W from 5 to 60. Here we have W. Remember, average rate of change is just slope, so this will be W of 60 minus W of 5 over 60 minus 5. Okay? And then you plug and chug on your calculator. Make sure that you group the numerator and the denominator so that you get a final answer. The other part you can do. I feel like you guys can handle that one there. But notice how AROC and average value are really easy to take care of. Okay?